Welcome to True Projects. In this video, we are going to explain about the project that is lung cancer detection, a comparative approach using regressor methods. So before getting into the execution, first let us understand what is this project about. Lung cancer, which is one of the most serious health problems worldwide and it is leading cause of cancer related deaths. Detecting it early is very important because early detection greatly increases the chance of successful treatment and survival. Doctors typically use medical imaging techniques like X rays, CT scans, MRIs, and sometimes genetic tests to identify tumors or cancerous cells in the lungs. So, here the challenge is that in its early stages, lung cancer can be very difficult to spot. Traditional diagnostic methods may miss subtle signs, which can delay diagnosis and reduce the effectiveness of the treatment. This is why improving early detection methods is so crucial for saving lives and giving patients the best possible outcome. So, to overcome with all such issues, the system we are proposing uses machine learning to predict the chances of someone having lung cancer based on their personal information. So, we are working with a data set of 306 patients, and for each patient, we look at 16 different factors. These include things like age, whether they smoke or not, if they experience anxiety or fatigue, chest pain, and other health related details. So basically, the system analyzes all these details to learn patterns that can indicate whether a person might have lung cancer or not. The goal is to make the detection process faster and more accurate, helping doctors identify potential cases earlier. So here, the system uses several different machine learning models. It uses 10 different machine learning models to predict whether a patient might have lung cancer. These models have different ways of learning patterns from the data, and some of the popular ones include decision trees, random forest, support vector machine, k nearest neighbor, and gradient boosting, and the others. So before making predictions, the system also looks at different patient features. So before making prediction, the system looks at different features and makes some adjustments. Features that don't seem to have much connection to lung cancer are removed, while features that are closely related are combined. This helps the model focus only on the most important information and improve the accuracy of the predictions. And here, to check how well the models are performing, the system uses something called stratified k-fold cross validation. Basically, this means that the data is split into different parts and the models are tested on each part while keeping the proportion of patients with and without lung cancer the same. This way, the evaluation is fair and also accurate, and we can trust the results. By doing this, the system becomes a reliable tool for early detection of lung cancer. It helps doctors identifying potential cases sooner, make better decisions, and also start treatment earlier, which can greatly improve the patient outcomes. So here, to further improve the performance of this project, as an extension, we are integrating voting classifier, which is an ensemble model, and it combines multiple models to provide an accurate prediction. So here it will be combining multiple individual models to make an accurate decision. And also to explain those interpretations, that is to explain those predictions, we are incorporating explainable AI techniques, that is LIME and SHAP. So these tools show why the model made a certain prediction instead of just giving a result. This is really important because it helps both the users and also doctors understand the reason behind the prediction, making the system more trustworthy and transparent. It it is not just about knowing the answer, but it is also about understanding how the system arrived at that particular answer. Moreover, we have also developed a front end by using Flash framework. So we have developed a simple web application by using Flash framework. So this interface, it allows users to log in securely, enter patient information, and get the predictions about lung cancer directly from the trained models. So this makes the system much more interactive and easy to use. Doctors or healthcare professionals can use it in clinical settings to quickly assess a patient's risk, making tool practicable and help in day-to-day healthcare. Moving on to implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented the project. First, we have imported all the necessary Python libraries that are important for data handling, training the models, and creating visualization. Then comes data ingestion. At this stage, lung cancer risk dataset from the Kaggle is loaded into Pandas data frame, and this allows us to work with the data efficiently in the Python. Then comes data pre-processing. Here, any missing values in the dataset are handled by either removing them or filling them in. And here, categorical data like yes, or no features are converted into numbers so the models can understand them. If the data set has an imbalance, more healthy patients, that is, than the cancer cases, or vice versa, sample techniques are applied to balance it for better modeling techniques. Moving on, data visualization. At this stage, a correlation matrix is created to see how different features are related to each other. The distribution of the outcome, that is, whether the patient has lung cancer or not, is visualized to understand the data better. Then comes feature extraction. So at this stage, important features and the selected from the data set, that is, important features are selected from the data set, and the data is split into training and testing sets. So the model can learn patterns and they can be tested on the unseen data. And we have trained multiple machine learning models. And here we have used k-fold cross-validation to evaluate models reliably by training and testing on multiple folds of the data. And we evaluated all of them using accuracy, precision, recall, and FN score, and also confusion matrix. And explainable AI techniques are applied to explain the predictions and show why the model made certain decisions. And best performing model is saved for the future use. Coming to the web application. So here, a simple web interface is created using Flask, where users can enter patient information and the saved model is loaded. Input is pre-processed, predictions are made, and the results are returned to the user. So this is how we have implemented. Moving on to the algorithms used. These are the algorithms used in this project. And this is the extension model. And coming to requirements, to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap are required. So this is the overview of the project. Now let's execute it. To execute, let's open the code folder that contains source code files. These are the source code files of this project. Let's understand each of them. In this, we have raw dataset that we have used. So here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have Jupyter Notebook file. So this Jupyter Notebook file, it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the database file. And this raw data set is extracted and converted into this XLS worksheet. Let's open it. So this is the extracted data set. And here we have different attributes. So based on these attributes only, we will be training the model. And this is the target column, which is whether person has lung cancer or not. And here we have different attributes. We will be training the models on these attributes to predict this lung cancer. Now close this. So this is all about the code folder. Now let's execute it. To execute, copy the path of the code folder from the address bar of the file explorer. So I've copied it. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path and click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. So you have to copy it and paste it into any web browser. I've copied it and I prefer Google Chrome, so I will paste it in that. So paste the link here. Now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So let's get signed up first. Click on sign up and create an account if you have not created. For creating account, you need to fill in all these details. I have already created, so I will directly sign in. So click on sign in and give your username and the password. Now click on sign in. We have signed in successfully and redirected to this prediction page of the project. So this is the prediction page of this project. Now let's start doing prediction. For that, click on test. And here you can see parameters, right? So these are the important parameters for predicting whether the person has lung cancer or not. So initially we had total 15 features. From that, by using feature selection techniques, we have selected these 9 features. So let's understand them. First, we have smoking. That is whether the person smokes or not. Smoking is one of the biggest risk factors for lung cancer. Then we have yellow fingers. Yellow fingers, that is yellowing of the fingers, often due to nicotine statins. It can indicate long-term smoking habits. Then we have peer pressure. It is the exposure to social influences that encourage smoking or unhealthy habits, which can indirectly increase the cancer risk. Then we have chronic disease. It is the presence of long-term health conditions like asthma, diabetes, or heart disease that may affect the overall lung health. Then we have fatigue. It is the persistent tiredness or low energy, which can sometimes be a system associated with serious illness, including lung cancer. Then we have allergy. It is the history of the allergies which can affect lung function, but it is less directly linked to cancer health risk. Then we have alcohol consumption. So this is whether person consumes alcohol. Heavy alcohol indicate, that is heavy alcohol intake can contribute to overall health risks. Then we have coughing. It, frequent or persistent coughing, it can be an early symptom of lung problem, including cancer. Then we have swallowing difficulty. It is a trouble swallowing food or liquids, which can sometimes indicate underlying health issues affecting the throat or lungs. So this is all about the parameters. Now let's enter them. So let's open the test cases. So in this, we have the test cases. So these are the test cases now we will be giving as input. So let's check with this case where person does not smoke. So no, it is. Yellow fingers, it is yes. And pure pressure, it is no. And chronic disease is no. Then fatigue is yes. Then allergy is no. Alcohol consumption is yes. Then coughing is yes. And then swallowing difficulty is also yes. Now let's click on predict. So this given information, it will be pre-processed at the backend. It will be fed to the train model. Then train model will be giving us a prediction. So here we got the prediction that lung cancer is detected. And this lung cancer is detected with the confidence score of 94.6. And here we have the message for that. That is the lung cancer risk assessment indicates that lung cancer is detected based on the provided symptoms and the risk factors. And the analysis shows a high probability of lung cancer. And here are the urgent recommendations that has to be taken. Let's get back and do the other predictions. So let's check with this case. So smoking is no, yellow fingers are no, no pressure. Pure pressure is yes. Chronic disease is no. Fatigue is yes. He has fatigue. Allergy is no. Alcohol consumption is no. And coughing is yes. Swallowing difficulty is no. Let's click on predict. And here we got the prediction that it is not detected. Lung cancer is not detected with the 53% confidence score. And here we have the message and also recommendations. Now let's check with this case where there is smoking. Person smokes. Yellow finger is no. Pure pressure is no. Chronic disease is no. Fatigue is yes. Allergy is no. Alcohol consumption is yes. Coughing is yes. And swallowing, he does not have difficulty in swallowing. So let's give it as no. Click on predict. And here we got the lung cancer detection with the 86%, that is 86.9%. So lung cancer is detected with this percentage of confidence score in detecting this particular class. And here we have message as well as recommendations. Let's get back and start checking with the other case. So let's check with this case where smoking is yes, yellow fingers are no, and pure pressure is no, chronic disease is no, and fatigue is yes, allergy is no, alcohol is no, and all other values are no. Now let's click on predict. So here we got the prediction that it is not detected. There is no lung cancer for the person. Let's get back and check with the graphs of this project. So in this way, you need to do the prediction. So let's click on graphs. So here the first graph which we have is class distribution graph. This shows the class distribution of lung cancer sample outcome. So this blue color represents no cases, that is with the no lung cancer, and this orange color represents with the yes, I mean with the lung cancer. And here we have correlation matrix, which shows the correlation between independent features. So here we have confusion matrix, where on x-axis we have predicted label and on y-axis we have true label. And here we have accuracy of all the models. So here on x-axis we have all the models that we have trained, and on y-axis we have accuracy score. Similarly, we have precision score, and here we have recall score. Here we have FN score. So now click on log out. So in this way, the system helps to detect the risk of lung cancer early, giving patients and doctors a chance to take action sooner. By understanding personal health factors, it makes screening easier, faster, and more reliable, ultimately supporting better healthcare outcomes. So just by giving required input features to the application will be accurately predicting whether the person has lung cancer or not. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.